All right, today we're going to talk again about angles and their measures. We're going to be using our arc length formulas. Sorry, need a pen. We're going to be using our arc length formulas. You use this formula if theta is measured in radians. You use this formula if theta is measured in degrees. So the first thing they want us to do is they said Albert Juarez's truck has wheels that are 36 inches in diameter. So here's a wheel. It's got a diameter of 36 inches. It says if the wheels are rotating at 630 revolutions per minute. All right, they want us to figure out the truck's speed in miles per hour. So eventually I want to turn this into miles per hour. Well, I'm going to have to convert all these units. Well, the first thing I want to get rid of is, I'm going to do time first because that's easiest. So I'm trying to turn minutes into hours. Well, if I'm getting rid of minutes, I would put that on top. And to go to hours, there are 60 minutes in 1 hour. Now that would cancel. And now, right now, I'm in revolutions per hour. So I've got the hour part right, but now I need to change my revolutions to miles. Well, I don't know how many miles are in a revolution. What's a revolution? A revolution of a tire is 1 time around. That's the same as its circumference. So the circumference of the circle is the same thing as 1 revolution. So if I find the circumference, which is pi times diameter, then I will find what 1 revolution is worth in inches. And that won't be in miles, it'll be in inches. But it's okay, I can get from inches to miles. So my circumference will be pi times 36. So 1 revolution is worth pi times 36, and I get 113.1 inches. So the first thing I'm going to do is get rid of revolutions. So right now revolutions is on top. I want to get rid of it, so I'm going to put it on bottom. And I can go to inches because that's my conversion rate. In 1 revolution, there's 113.1 inches. Now that gets me out of revolutions, and now I'm in inches per hour. I don't want inches, I want miles. So I've got to get rid of inches. So I'm going to put that on the bottom. And I wish I could go straight to miles, but I don't know how many inches are in a mile. But I do know how many inches are in a foot. There are 12 inches in 1 foot. So that will get me out of inches. And now I'm in feet per hour. Getting closer. I don't want feet per hour. I want miles per hour. So to get rid of feet, I'm going to, let me erase this for right now. I'm going to put that on the bottom, and I'm going to put miles on top. And there are 5,280 feet in 1 mile. Now that's going to get rid of feet, and that's finally going to put me in what I want, which is miles per hour. So all I have to do is type in parentheses 630 times 113.1 times 60 divided by parentheses 12 times 5280 parentheses. So if I type all that in, parentheses 630 times 113.1 times 60 parentheses divided by parentheses 12 times 5280, close the parentheses, you get approximately 67.5 miles per hour. Okay? All right. And I kind of animated it all for you. All right, the next couple of examples that we're going to do, they're going to give you this circle, right? And they've got 2 concentric circles. Concentric means that one is drawn inside of another one, kind of like a target. Okay, and if you notice, if you look at the pink little pie right here that I just colored in with red, which you can't really see, this little one right here, okay, and then do you see this big one that takes up it all? They both have the same angle. Okay, so whatever, when I'm figuring out their different arc lengths, this angle is going to be the same for both of them. Okay, so what can I do? Well, they give me two sets of information, one for the first circle and one for the second circle. But we know in the second circle, this theta and this theta have to be the same. So I can't solve this one first because there's two question marks. I can solve this one first because there's only one question mark. So it doesn't specify what they want their angle in. They don't specify whether they want degrees or radians. So I'm going to go for radians since that's going to be the shortest formula to use. So I plug in 9 for S, I plug in 11 for R, and I leave theta theta. And to get theta alone, I divide by 11. And that's what theta is. Theta is 9/11. You can turn it into decimal if you want to, but that's theta, radians. Okay, and that's got to be the same thing over here. Theta is 9/11 radians. So now I only have one question mark over here because now I know this. So now I can solve for the arc length of the second circle. And I do arc length, which is what I'm looking for, equals my radius, which is 44, times my theta, which is 9/11. Type that in and you get an arc length of 36 centimeters. Okay, and 34 would be the same way. All right, this one says it takes 7 identical pieces to form a circular track. What that means is, guys, remember when you were a little kid and you put those tracks together? 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Sorry. Okay, so you have these 7 pieces of pie that you click together, and then there was the track that the cars went around and around and around and around on. Okay, so that's what they're doing. Well, basically it says that the inside arc is 2.8 inches shorter than the outside arc. So if I do the outside arc and I subtract the inside arc, that has to be 2.8 inches. Okay, so there's my formula. I just got to figure out these guys' arc length. Well, to get their arc length, I need to figure out what theta is. So theta, if it was in a whole circle is worth 2 pi radians, but I'm cutting that into 7 pieces. So my theta is going to be, if I type in 2 pi divided by 7, I get 0.8976. Okay, so there's my theta. Now, to get this first arc length, this outer arc length, okay, it will be its radius, which I don't know, let's call that radius 1, times theta, which would be 0.8976, minus, if I calculate the arc length of the inner circle right here, that will be its radius, let's call it radius 2, times its theta, which is the same as his theta, which is 0.8976. Yes? Yeah? So I replaced this with equivalent values. I replaced this with equivalent values, and that has to equal 2.8. Well, you see how both of these terms have this touching it? Then I can GCF that out. If I factor out 0.8976 from both of these, then I have R1 minus R2 left, equals 2.8, yeah? And isn't that what I'm trying to figure out anyway? If I'm trying to figure out the width of the track, well, if this whole thing is R1 and just this much of it is R2, if I take R1 minus R2, what's left is the width of the track, right? If I take this whole long thing and I take off this much, all that's left is the width of the track, which is R1 minus R2, which is right there. So I want to get that alone, and I'll have my answer. So to get that alone, I'm going to divide by 0.8976, and I get the width of the track is equal to 2.8 divided by 0.8976, and I get 3.119. So let's call it 3.12. The width of the track is 3.12 inches. Yeah, the width of the track. Okay. All right. Let's see. Yeah. Sorry, I did some animations here. Okay, on this one, it says the concentric circles of an archery target are 9 inches apart. So the difference between the outer circle and the inner circle is 9 inches. It says the inner circle, red, has a perimeter of 45 inches. What is the perimeter of the next largest one? All right, well, what you got to know here is they're giving me perimeters of circles. Perimeters are circumferences. Okay, so the circumference of the inner circle will be pi times diameter. Well, I know the circumference is 45, and that's going to be pi times the diameter. Now, the diameter of the little circle, I don't know. Okay, from here to here would be the diameter of the little circle. So I don't know it, so I'm going to keep it d. So to figure out what the diameter is, I'm going to divide by pi. And the diameter of the little circle, 45 divided by pi is 14.32. Okay? So now I can use that, because now if I know that diameter, all I have to do to figure out the diameter, again, because what they want is the perimeter of the big one. So again, I'm looking for the circumference of the outer one. Well, that's what I'm looking for. It's pi times its diameter. Well, isn't its diameter going to be the smaller one's diameter plus 9 on this side and plus 9 on this side? So isn't his diameter going to be the 14.32 plus 18? It is. So to figure out the circumference, I just multiply pi, parentheses, 14.32 plus 18, close your parentheses, and you get the circumference is 101.55. There's the circumference of the big one. Alright, and the next example. To the nearest inch, find the perimeter of a 15-degree sector cut from a circular disc of radius 14 inches. Perimeter means distance around. Okay, they're telling me that the radius is 14. So that's 14, that's 14. And I'm looking, to get the perimeter, I'm going to have to add this arc length to it. So I'm going to have to find the arc length. Well, I'm using this formula because they gave me my angle in degrees, not in radians. So to figure out that arc length, it's going to be pi times the radius times theta, which is 15 degrees, divided by 180. So if I type that in, I get 3.665. So now my perimeter of the whole sector is going to be 14 plus 14 plus 3.665. And the perimeter of that whole sector will be 31.67 inches. Okay? Alright, next they want to find, it says an 85-degree arc of a circle. So they're telling you that the angle is theta is 85 degrees. And it has a length, the arc has a length of 6 inches. To the nearest centimeter, what's the radius? Again, since they gave me degrees, my angle in degrees, I have to use the long formula. And so gave me the arc length is 6. Pi times the radius is what I'm looking for, times theta is 85 over 180. Alright, to solve this, I'm going to multiply both sides by 180. And I get 10,080 equals 85 pi r, because those cancel. So to get r alone, now I'm going to divide by 85 pi. And that gives me my radius of 4.04 centimeters. Okay? Alright, next we have two boats that leave Cape May at the same time. One traveling with a bearing of 52 degrees 20 minutes and the other with a bearing of 64 degrees 25 minutes. If they travel at the same speed, approximately how far apart will they be when they are 40 statute miles from Cape May? What that means, guys, is they both, even though they're going at different angles, their radiuses are both 40. Okay, they've both gone 40 miles out. And what they want to know is what is the distance apart between these two? Well, again, we're looking at the distance of the difference in their arc lengths. Okay, so if I want, S2 minus S1 is going to, if I can get this arc length, which would be S2, and I can get this arc length, which would be S1, and I subtracted them, that's going to be how far apart they are. Well, I've got the radius and the degrees. All I need to do is calculate the arc length. The problem is they make it a little pain in the butt because they give us our angle with degrees and minutes. But for 64 degrees 25 minutes, 25 divided by 60, this theta is going to be 64.42 degrees. And if I take 20 divided by 60, I get 0.3 repeating. So this theta is 52.3 degrees. Let me hit pause for the announcement.
Start rapping and packing.
You guys! Alright, so back to where we were. Alright, so we've got two boats that leave Cape May at the same time. We were figuring out the degrees. Okay, so we took 25, divided it by 60 and got the 0.42. Then we took the 20 divided by 60 and got the 0.3 repeating. So for the big arc length, it's going to be its radius, which is 40, times its angle, which is 64.42. Crap, I'm using radians. Sorry. So S2 would be pi times the radius times the theta, which is 64.42, divided by 180. So if I calculate that, I get, trust me, S2 equals 44.97. To figure out S1, I'm going to take pi times 40 times 52.3 repeating divided by 180. So I get S1 is equal to 36.5, and I just typed all that in the calculator. So now, to figure out how far apart they are, I need to subtract the arc lengths. So I take 44.97 minus 36.5, and I get 8.47 miles. They're about 9 miles apart. This is what you're going to be doing next year, by the way. Alright, so the next one says, a radial arm saw has a circular cutting blade with a diameter of 10 inches. It spins at 2,000 revolutions per minute. If there are 12 cutting teeth per inch on the cutting blade, how many teeth cross the cutting surface each second? So, oops. Sorry, I gotta back up. So, what we're gonna do, they're giving me 2,000 revolutions per minute. Okay? They're giving me 2,000 revolutions per minute. So I'm starting off, oh my gosh, my pen. So we have 2,000 revolutions in 1 minute. And they want me to go to teeth per second. Okay, I'm trying to get to teeth per second. Well, the first thing I'm going to do is I'm going to get rid of my minutes and I'm going to get to seconds. So if minutes are on the bottom and I want them to go away, I put them on top. Seconds are on bottom. There's 60 seconds in 1 minute. That's going to get rid of minutes and put me in revolutions per second. So I've got the second down. Now I need teeth. Well, teeth on this blade, right? 1 revolution would be the circumference. And the circumference is going to be pi times the diameter, which is pi times 10, which is 3.14 times 10. So the circumference, which is 1 revolution, is equal to 31.4 inches. Okay, so 1 revolution is equal to 31.4 inches. So I can get rid of, I want to get rid of revolutions. I was going to say revelations. I can get rid of revolutions by putting that on the bottom, and I can go to inches because that's what the arm is measured in, or the wheel, or the saw blade, whatever. So in 1 revolution, there's 31.4 inches. Now that gets me to inches per second. I don't want inches per second. I want teeth per second. So if I want to get rid of inches, I put it on the bottom, and I want the number of teeth, I put that on top. And it told me there's 12 teeth per inch. So 1 inch is worth 12 teeth. That gets rid of inches and puts me in feet per second. So all I have to do is figure it out. 2,000 times 31.4 times 12 divided by 60. So if I type that in, trust me, I already did it, you get 1,256 teeth per inch. Okay? Wow. That's a lot of teeth hitting an inch. I guess that's why it cuts it so good. I'm going to make myself laugh. Okay, so hit pause. Come back when you're ready. And hopefully you got 452. So it says the radius of a car wheel is 13 inches. So if the radius is 13, the diameter is 26, and 1 revolution, or a circumference, is pi times diameter. So it would be 26 pi, which is 81. So 1 revolution is 81.68 inches. All right, so it says, how many revolutions per minute is the wheel making when the car is traveling at 35 miles per hour? So we're kind of going backwards here. Now they're starting us at miles per hour. I want to get rid of hours, okay, because they want revolutions per minute. So I want to go from hours to minutes. So to get rid of hours, I put hours on top, minutes on bottom, 60 minutes, 1 hour. Now I'm in miles per minute. So at least I got the minute part right. Now I got to go from miles to revolutions. Well, to get rid of miles, I put it on the bottom, and I can go to feet. There are 5,280 feet in 1 mile. So now I'm in feet per minute, which I don't want, so I got to get rid of feet. I can go from feet to inches. There's 12 inches in 1 foot. Those cancel, and now I'm in inches per minute, which I don't want. I want revolutions. So to get rid of inches, I put it on the bottom, revolutions on top, and I already figured that out up here. 1 revolution is worth 81.68 inches. That will cancel my inches, and now I'm in revolutions per minute. So all I do is multiply the top, 35 times 5280 times 12 times 5280 times 12 divided by 60 times 8168. And if you do all that, you get 452.49755, blah, blah, blah. But it said to the nearest revolution, so that's going to leave it 452. Okay? Next, it says the pendulum of length 16.1 inches. So this length here is 16.1. Okay. It says it swings 3 degrees 33 minutes to each side its vertical position. Okay. To the nearest hundredth of an inch, what is the length of the arc? So they're asking me to figure out how far it swings. That's arc length. And my formula for arc length when I'm given degrees is right here. Now we've got to change this. So if I take 33 and divide it by 60, 33 divided by 60, that gives me 3.55 degrees. Now I got to double that because that's just one way. The whole angle is that twice. It's each way. So if I double that, I get 7.1. Okay, so that's my angle, that's theta. And I know the radius is 16, it told me that. So in my formula, to get the arc length, it's pi times 16.1 times 7.1 divided by 180. And you get S equals 1.995085, blah, blah, blah. And I think it says to the nearest hundredth. So that 5 would bump that up. Bumps that up, bumps that up, and it's 2 inches. Okay. Alright. So, come on. A little slow. Sorry. 2 inches. Alright, and then on this one, it says a wheel with a 36-inch radius is marked at 2 points on the rim. The distance between the marks along the wheel is found to be 3 inches. So they're telling me the arc length is 3. And they're telling me the radius is 36 inches. And they want to know the angle to the nearest tenth of a degree. Because they're asking for degrees, I have to use the degree arc length formula. So I substitute 3 for S, 36 for R, theta is what I'm looking for, over 180. So when I solve this, I'm going to multiply both sides by 180, I get 540 equals 36 pi times theta. So to get theta alone, I'm going to divide by 36 pi, and I get theta equals 4.8 degrees. All done. Okay. And come on. All right, and then the rest you have your conversions between statute mile and nautical miles. And it depends on which way you're going. And you can use either one of these. Why they give you both, I'm not really sure, but either one works. So part of your homework is they're going to ask you to sketch a diagram of a ship of the given course. What you have to remember is that when you travel on water, it's different than traveling on land. North, nautical north, okay, would be pointing up. All right, and you start from a standard position, which would be on the horizontal. So to go 35 degrees, well, 45 is exactly halfway between. So I don't know, 35 is about maybe right there. Okay, so that would be, oh, no. No. I'm a schmo. You know what? Let me look at something real quick. Yep, I was wrong. Okay, back up. My bad. All right, I'm sorry. I knew there was nautical north for some reason. When you're sketching on nautical things, you have nautical north, which is what points straight up, okay? And you measure from nautical north your degrees. So if 45 degrees coming down would be halfway. So 35 degrees would be probably about right there. Okay? For 128 degrees, here's nautical north. There's your horizon. All the way here would be 90. All the way here would be 180. So 128 is probably somewhere about over here. That would be about 128 degrees. And then your 310, again, here's your nautical north. All the way around would be 360. So 310, I don't know, maybe about right there. And that would be your 310. This one, it's a little weird, okay? You start off and you go for at a course of 38 degrees for about 2 miles. So from nautical north, you head off this way and you're going 38 degrees from nautical north for 2 miles. You know what, I'm going to do this down here. So I'm coming off nautical north. You're going to come out about 38 degrees about doing this. So from here to here is 38 degrees. Now, once you've gone 2 miles, you stop. And that makes your new nautical north this way again. So from this way, then you go 47 degrees. But here's your new horizon. Well, halfway would be 45, so a little more than that would be 47. Okay, there's 47 degrees from nautical north. So your path would be 2 miles here, and then you would go this way, and there would be your path. And then the last problems are just converting between statute and nautical miles. They're giving you 257 nautical miles, and they want to know how far apart that is in statute miles. If I want nautical miles to go away, I put it on the bottom. Statute miles goes on top, and you can use either one of these. I promise you'll get the same answer either way. I'm going to go with this one. 1 nautical mile is 1.15 statute miles. So these cancel, and I'm left with 257 times 1.15, and I get statute miles is 295.55 statute miles. Okay, so this one gives me 895 statute miles apart, and they want to know how many nautical miles. So if I want that to go away on bottom, nautical miles on top, and I'll use the other one just to show you. 1 statute mile is 0.87 nautical miles. Those cancel. Multiply 895 times 0.87, and you get 778.65. So it says, how many degrees does the minute hand of a clock travel in 45 minutes? Well, guys, 45 minutes, it would travel like this. Count those degrees. All right? No, not the degrees. In 45 minutes. Oh, yeah, they're not asking for the arc point. No, we'll just figure out that angle, guys. There's 360 total. Take 90 away, and that's going to be your... I think I meant for how far does the travel on the outside. Anyway, we are at homework, so we are done. Happy homeworking, and I will see you next time.